Good morning, good afternoon, good evening. Welcome to another episode of OpenShift TV. I am live today with the one and only JJ Asgar from IBM. JJ, I am Chris Short. You are JJ. Would you like to introduce yourself, sir, to the audience?
Sure. Thanks, Chris. Yeah. Hi, I'm JJ, as he says. I'm a developer advocate for the IBM Cloud. And Chris, we've known each other for what? Going on
Ooh,
4 years now?
No, we met in like 2016. Yeah, like 4 years now. Yeah. I think we met at All Things Open. It was 2016 or 17, maybe 15. It might. Yeah. Like we've known each other for a while now.
Yeah.
We've been in similar circles for a long, long time, like way before the IBM Red Hat thing.
It's true.
and now we find ourselves in yet again similar circles
Exactly.
after all this time.
It just dawned on me. We met at ChefConf, where you were speaking just before I was.
Right.
That's
yes.
right. And
okay,
I was like,
so that was 2016 or I don't even, I forget, 2018 maybe? I don't know. But yeah, ChefConf. That's cool. Yeah, that's where you met. Yeah. And oddly enough, at ChefConf, I was negotiating for the job to take me to Red Hat. So
nice.
Yes. Nice. Yes, it was them and PagerDuty. They were in the running. Obviously, Red Hat won, even with the IPO and everything. But the long story short, JJ and I have known each other for a while. And I call JJ a friend, and we are finally now able to get together on this wonderful channel to talk about COBOL, of all things.
Of all things.
Of all things. And I know that doesn't sound maybe appealing or interesting to some people, but guess what? My life runs on COBOL. Most of your lives run on COBOL. And why is that, JJ? Do you have some stats around that potentially?
Actually, I have a very nice slide that I'll show in a little bit with some good stats on it.
Okay, cool. So we'll hold off on that. But yeah, so like my first interaction with COBOL was literally my marketing teacher telling me in 93 I should learn this. And it was like, okay, why? I was already in like the Windows world. I was already like the sysadmin type thing. She was like, this is where most of the work actually happens. And this is my marketing teacher at the time, which, I credit for a lot of things that she taught me. But like, she knew that COBOL wasn't going to go away in 93 because it had been around so long. And she was telling me at the time, being interested in tech, that I should learn COBOL, which I thought was just remarkable. And it's so intriguing to me that all these years later, I might understand some COBOL, but I've never really, like fully grasped it, right? Like picked it up and like done anything significant with it. But you're going to give me the opportunity to, which is rather rad, I feel like.
Yeah. So yeah, my whole story here is, and I'll bring up the slides to kind of walk through everything, but luckily your audience is very advanced in the Kubernetes cloud native ecosystem. So I'm going to try to focus mainly on the COBOL aspect of this. But I have a whole story about kind of showing COBOL engineers why they should care about cloud native, right? Also, I will say, Jason Dobies and Brian Tanis and I actually got this working on OpenShift also. So I have the same repository forked and working on OpenShift, but because of, for lack of a better term, my preparation, I don't have an OpenShift cluster up and running that I could show it on OpenShift, but let's not risk ourselves here. I'll just do the Kubernetes one, but I'll still link to the OpenShift one, so we can talk about that too.
I'll let you slide on that one, but I don't think you realize that I speak softly and carry a spare OpenShift cluster around these parts.
That's beautiful. That's beautiful.
But yeah, so to be honest with you, I have a OpenShift cluster across the house. It is standing there ready and waiting for any kind of muckery. It actually came into use last week. We broke it to an extent that last night I had to rebuild it. I just decided to give up on troubleshooting and fixing it. I was like, screw it, let's wipe it and start over. But then, on Tuesdays and Thursdays when we do like our office hour show, I always spin up an extra cluster just in case someone is testing something and it breaks. right? Yep. So I do have a spare cluster sitting here right now, just in case. Just in case. You never know.
That's good. Yep. So do you mind if I share my screen?
Please feel free. Yeah, like have at it. Let her rip, man.
So let's see here. And I went ahead, as I say before, every time I share my screen, if anything embarrassing pops up when it happens, I apologize ahead of time.
You will not be as bad as the New York Times article I read on my walk just now. I promise you that.
All right. So hopefully you should be able to see Kubernetes, OpenShift, and COBOL 2. Yep.
One big happy pool. Let's all jump in.
Wonderful. So yes, again, hi, JJ, developer advocate for the IBM Cloud. Yes, I do have that email address of awesome@ibm.com.
That's where the invite went. Yep.
Yep. I do plug it whenever I can because, part of my job is as a developer advocate is I'm supposed to be a human you can actually talk to, right? Like that's my job. I'm supposed to be accessible. If you have any questions about the IBM Cloud or if any of the technology that I talk about, I want you to reach out to me. Like that is my whole the reason why I am paid. You'd be amazed on how few people actually do it. So if you ever think about it, please never hesitate. And then there's my Twitter handle too. If you like to go through Twitter, sometimes it's faster than email. So cool. Okay, so I'm gonna talk about just a couple of things. Again, normally I start with an overview of Kubernetes or OpenShift. I use the term Kubernetes and OpenShift back and forth pretty regularly.
Yeah. We're used to that here.
Apart from times where I'm going to specify OpenShift specifically for the amazing additions that OpenShift gives you on top of Kubernetes to be successful. Again, this audience obviously is from the OpenShift world. You already all know this, so I'm just going to shoot right through these things so we can get the actual COBOL. I'm going to talk about how this kind of project came together, just to kind of give an overview. And hopefully, if somebody has some questions. By the way, Chris, I am not watching the chat, so if somebody does ask, please. Perfect. And then we're going to go ahead and build a simple ETL pipeline using COBOL and run it actually on a Kubernetes cluster. It's going to be on the IBM Cloud for obvious reasons.
Sure.
And
I'm going to
hawk. Yeah, exactly. I'm gonna hawk a couple of other little open source projects that I've kind of got going. So hopefully, if you are interested in this, you can absolutely try this at home.
Yeah.
And please, again, Chris, interrupt me. Be like, JJ, what? I'm here to answer questions and kind of have conversations.
Like just for, since you used an acronym, ETL.
Yeah. Okay. So, and by the way, if you notice, I am looking over to the right-hand side. That's where the video of your picture is.
I like talking to you too.
Yes. So exactly. So ETL means extract, transform, and load. Pretty sure that's what it stands for. So if you actually think about the majority of ways things are done in a bank or major industries, pharmacies. They take some data from somewhere. Yep. They take some data from something. They manipulate it, as you can see with my hands. They manipulate it, and then they load it into something else. That's how banking is done. If you think about it, in the corest part of like when you gave money to a bank teller, they extracted money from you, they transformed some data, and they loaded that into a saying that yes, you gave them $10 or whatever.
Wow. Yeah. So I like how you put that so simply. Yes. Yeah.
Yeah.
Even with the ATM, yes, you inserted a $10 bill.
Yes. And now it transforms the data to give you that. So what we're going to do is build that exact same pipeline, which is the lion's share, not all, the lion's share of how COBOL applications are ran in modern day. If you imagine, where did most of the COBOL come from when it started becoming, when we started using computers as a society? Banks needed to figure out how to process money. Records from the VA, things like that, were required to be exported, transformed, and loaded into something. So, yeah.
So I mean, I can tell you a story about the VA. My first interaction with the VA was checking in to the VA clinic there in Durham, North Carolina, and the poor lady was she was like, you you look like you might be, I was wearing like a tech shirt. You look like you might be into tech. Like, can you help me with something real quick? I was like, sure. What's going on? She's like, I just need to open this. I need to run this one command. And I was like, okay. And I walk around the desk and there it is, DOS 622 with some mainframe, 2E kind of thing going on. And I'm like, oh goodness, what have I gotten myself into here? And it's like, no, wait, these records have been in the VA mainframes forever. And guess what? They'll be there forever, probably, because it is such a robust set of data. Doing an ETL to put it someplace else might be insanely expensive. Like when I say insanely expensive, I'm talking like numbers that with zeros and magnitudes and stuff, right? Like but that was my first like real interaction with the VA, was actually getting the lady back into her app so she could then fire some COBOL commands back and forth through a mainframe. Yeah, pretty cool.
Amazing. It's amazing. Okay, so let's just kick it off. And again, I'm going to go through these real quick so we can get to the actual meat of the conversation. So as we all know, inside the cloud native ecosystem, everything's built off of a container. And I do this tongue in cheek over here in the corner because I was told by my marketing people I'm not allowed to use the Docker logo anymore. So yeah, that's where the Docker logo should be. We all know, we all use Quay, right? We all use Quay. Yeah. Oh, really? Okay. I thought that was a good plug. And then we build containers. We distribute them using a Docker registry. Everything's built from a Docker file, as we know. And it's the beautiful, it runs on my laptop as long as I have and I adhere to the OCI, as long as I have a container runtime, it will run. That's nice. the promise of a container, as we all know. Now, as you start going deeper into the world, that's where Kubernetes comes into play. Because now, instead of me just running it on my laptop and shoving it off into some ether to run, you need a way to orchestrate it. That's where Kubernetes comes into play. Most important to know about Kubernetes, as we all know, it's community supported. There are professional offerings like IBM Cloud, but it is the actual upstream is done by the community. It's not, there's not one company behind it. That's actually could be a problem in a lot of the cases because, companies like throats to choke if something goes wrong, and there's other options. There's issues with it. Also, in the Red Hat, one of the disadvantages of Kubernetes is there is no long-term support. Because there's no company behind it. There's quarterly minor releases, and it moves very fast. So you need to always stay up with it.
As a matter of fact, we were talking about potentially slowing down. There's actually an enhancement request open just this week talking about maybe we should go to 3 releases a year. What would that look like? So we are thinking about it as a community, but I think people don't realize just because it's 3 releases, it makes the release bigger, even though it's less frequent. It's still probably as much work. So, just because you're not going through, a couple extra cycles of stuff might not be the payoff. So yeah, we're having that discussion internally, but yeah, right now it's every quarter there's a new Kubernetes release, and I'm working on the 120 team right now. Nice.
And I'm oversimplifying it for this audience, but this is a great way of describing it. If you actually look at the core framework, what Kubernetes is, it is a very limited scope of what it can and cannot do. And that's the reason why landscape.cncf.io is so massive, is because they're leveraging the ecosystem to add on the additional things. So there's a lot more there to think about, but we all know Kubernetes is it's the engine of your car, if you will, and you've got to think of your steering wheel. You've got to think of all the other stuff. I guess the application would be the gas in this. I've already lost the analogy, but you get my point.
Yeah.
More importantly, and again, I'm on OpenShift.tv, so obviously you all know this, but again, this is my presentation. This is our production grade open source version of Kubernetes, supported by Red Hat, as we all know. True long-term support, which is always great, especially if you're an enterprise where you might not have cycles that you can update every like twice a year or quarterly releases. You need to think about massive things going on. And there's some amazing, and I describe this as guardrails, usually in conversations, that OpenShift gives you as a developer that allows you to get the velocity you need as an enterprise developer to get your application out the door. The happy path of OpenShift is phenomenal, and I've been converted when I started seeing the beauty of it.
Okay, all right.
I really did. So if whenever I speak, I really do try to make sure that OpenShift is the forefront, and because it is just Kubernetes, I use it back and forth interchangeably to make sure that it is just part of my vernacular.
Yeah.
Okay, so back to the ETL pipeline and what we're going to eventually get to. We're going to build a pod, and this is what pods are, as we all know. I'm just going to shoot right through that because we all know what that is. We all know what a deployment is because that's how we say, hey, run these many pods on my OpenShift or Kubernetes cluster. If you have a deployment, failure recovery, something blows up, it gets scheduled somewhere else. Yay, happy days. Nodes.
Go, scheduler, go.
Exactly. This is something usually trips people up, and I try to make this very clear, is that in the old ways of doing computing is a verb, I guess, you used to have to know where your application was running, what Tomcat server on what VM in whatever data center was running. So you got trained to identify where things were. Because the way Kubernetes was ran, a very simplistic way of describing it, but if you really, really put your mind to it, all it is an API to shared compute. That's when you boil it down. So you say, hey, Kubernetes, run this container, and it figures out, the scheduler, somewhere to run it. So as you can see here, even though I have 3 nodes here, which could be three laptops, 3 VMs, 3 data centers, who knows? It doesn't matter because the Kubernetes cluster actually takes ownership of scheduling and running it. I don't need to know where these machines are. All I need to know is my API endpoint to give it the container to run. Is that right, Chris? Did I say anything wrong?
It sounds like you nailed it to me.
Cool.
There is a question in chat.
Sure.
And I'm pretty sure it's already out. I don't know. When will IBM Cloud offer an OCP for Z? I thought we released that.
Guess what? I have a link at the very end of this, which we might have a link to something along those lines. Yes.
Okay.
So yes, it is out.
It is there.
I can absolutely give you those links here in a moment.
And I have it too. Yeah. Stick around.
Yeah, exactly.
It's there. Don't go anywhere. It's available. Yeah.
Yes. It's really cool. It really is cool, especially if you live in the Z ecosystem. Having the OpenShift interface, right. It really is cool.
Because I just can't imagine, right? Like I remember talking to Kelsey Hightower about like running Kubernetes on a mainframe, like off to the side one day at a conference, and I was just like, that would be so cool. And here we are.
Exactly. Oh, it's wonderful. Okay, so we all kind of see the little building blocks of how everything comes together. Let's talk about some internal concepts to make sure that we're all speaking the same language, which we already are. But again, this gets us to the ETL pipeline of what we decided was the best way to show off this COBOL and Kubernetes. Because we all still network admins deep down inside. We all have DNS. And of course, the Kubernetes and OpenShift cluster has DNS inside of it. It's called kubedns. That is how you declare foo-web. So when pod A needed to find the service on foo-web, having kubedns to declare, and you can talk to pod C tick to end numbers. There's different ways of doing services, but the core of it, this is how you would map foo-web if you're doing a request. Moving into the microservices world, you're probably using some type of REST API or whatever type of API you decided, and you are going to be doing HTTP calls or HTTPS calls back and forth. So you need some type of DNS. So it takes care of that. kubedns is the bane of my existence right now. And I would love to, that's a different conversation for a different time.
Okay. I mean, I love core DNS. That's what's at the core of kubedns. Maybe I can help you. I don't know.
So I've been doing Kubernetes the hard way as one of my streams.
Okay.
And I've gotten the clusters up and running, but core DNS for some reason, I've got it working on IBM Cloud in the VPC Gen 2. It actually works.
Okay. Yeah.
But I can't seem to land the final thing, and it is core DNS that is breaking me.
Interesting.
Yeah.
Okay, maybe I should come on your show and help.
Oh, that would be amazing.
Yeah. I've done some. Yeah. Let's talk about that afterwards. Yeah.
We're just gonna get a checklist of things to talk about before we know it, Chris.
I know, it's gonna be great.
Oh, it's great. Okay, it's good. And by the way, for people who are watching, this is truly live. This is us, Chris and I, just literally riffing off of each other. This is how we work together. Like, this is just going back and forth. It's great. Okay, so node ports, don't use these, but they do exist. It is a way to always point port 80 of foo web to port 5000 on that specific pod. It's designed for a one-to-one relationship. It was originally designed as a debugging method, but unfortunately there's some companies out there that decided to use it for their main ways, and it exists. Use it if you have to.
Yeah.
But there's better options, which we'll get to in a moment. The most important thing to know about inside of Kubernetes and OpenShift, and for right now, is something called namespaces. And this is one of the things usually people struggle on when I'm talking about it, because the enterprise engineers that I talk to, they still probably typically have their normal waterfall process, right? Where they're typing on their laptop, push the thing into staging, and staging is under Jane Doe's desktop over there that kind of is close to production, but nowhere near what it is compared to their laptop. And then when they push it out to production, it goes from Jane Doe's desktop to random DC, and they've noticed that it's completely different hardware, completely different infrastructure, whatever. Well, the beauty of namespaces is that in the simplest terms, obviously there's caveats to all of this.
Right.
You can stamp out the exact same manifests in walled gardens for your application. So as you see here, foo web, these two foo webs for your application and my application cannot talk to one another. So simplest terms, I know there's ways to get around it, simplest terms. But take it one step farther, imagine dev, QA, and prod being all on the same hardware inside your data center. So then all of a sudden you're not worrying about Jane Doe's desktop being staging anymore. Now you're actually producing something out into the actual real world where you could actually see it work in the real with real data, in essence. If you have like a database that's, outside of your Kubernetes cluster, you can actually connect to the same hardware with a different database, and you actually see, oh, there's latency between the Kubernetes cluster and our database or whatever, right? Yeah. There's so many advantages of just using namespaces in that aspect.
Yeah, namespaces by themselves are just resource allocation, quotas and all kinds of fun boxing, right? Like it keeps you safe from your other things as long as you're not doing bad things and running the latest Kubernetes, which is often, hard for folks. So yeah.
Is it the hard way? Hey,
I see what you did there.
There you go.
We're making it easier. Take
it one step farther. And OpenShift has these things called projects, as we all know. And J-Dobbs described it so well to me when I finally got my head wrapped around projects. I realized this might be a little bit not official, but this is how it got to me. Projects are like Git branches.
Yeah.
Where if you imagine, you can create an n number of projects. It doesn't matter. So you could actually iterate with an OpenShift cluster, with a new project of like the date of you trying to get something done. And when it finally gets to the point where you're ready to push it into, for instance, payment dev, so other people can see what's going on. And then you can promote it, if not obviously this person, because they can only go to payment dev. But if I had access to payment prod, I could take that exact same way and manifest and push it into payment prod. Projects are designed to be, the namespaces cranked to 11. They truly are. They give you as a developer the guardrails that you need to be able to iterate quickly, as a developer should. And then when you get to the production level or something push out to something more than just you have the RBAC around it to make sure that you can get where you need to. This is usually where I keep forgetting to put this graph in this project or this presentation, but there's that famous graph of iterative times of how much it costs on a developer laptop and moving to staging to production.
Yes.
And how it gets exponentially more and more expensive. Using projects inside of OpenShift, you get that iterative same hardware that your production stuff is running on in a way, so you can iterate quickly and be very, very cheap. So it's a really, really nice way to describe what's going on here.
Yeah, I like to when people are like, okay, why do we need containers? I often say, okay, why did we need VMs? Well, we needed to increase density in the data center. Same reason, right? Like, and so like these projects and namespaces, which namespaces are the Kubernetes native component. Projects are a thing we've built on top of namespaces and OpenShift, because projects came out before namespaces, I think. I can't remember which happened first, or maybe we needed a little. Okay.
Pretty sure
namespaces was a core thing of, never mind.
Yeah.
I don't know what I'm talking about. No, it was route and ingress. That was the two things that were different.
Yes.
Never mind.
Yep.
Sorry. I get confused with those. So namespaces are like a Kubernetes native thing. Projects add a little bit of functionality to the namespaces so that you can have, A, as many as you want of them, and B, treat them as, more ephemeral type projects, as opposed to like hard-coded namespaces where it's like, they are just as simple to create and destroy, yes, but there's a little bit more functionality and a little bit more, tightness you can put on who can do that with a project versus a namespace, right?
Absolutely.
So
So I mentioned earlier node ports, which you should be using are load balancers. It could be its whole talk in itself, whole narrative around that. There's even ways to rip out the load balancer and put other load balancers inside there now. Read the docs. That's the best thing I can say to you. But the beauty of the shortest way, as we all know, which we're actually going to show in this experiment, but the load balancer allows you to talk to n number of pod C in this case. So when node ports only went from 1 to 1, load balancers are 1 to many. And that's the most important thing about, because it's the whole point, right? Kubernetes is that you're running n number of pods where you have no idea where they are. You need some way to talk to it. That's where a load balancer comes into play.
And there are so many ways you can load balance now in Kubernetes. It's pretty fun.
Oh, so many.
Oh yeah.
It's overwhelming. It truly is. But
I am doing a talk later this week for a meetup, and I do show the cloud native landscape. And I refreshed it this morning as I was going through the slides, and I was like, good Lord, this thing just keeps getting bigger.
I thought we fixed this with the OpenStack ecosystem back in the day, but why did we take that worst part of anyway. And
1,001 ways to do everything with computers.
It's so true.
It's so true.
So ingress is the way to map your application inside of a Kubernetes cluster. I'm not going to go farther than saying just that, but it's the way that you can declare how everything kind of fits together. It's the hardest, in my personal opinion, as I was learning Kubernetes and trying to explain it to people, it's the hardest thing for people to really grasp. Best way to learn, especially if you've never touched this stuff before, is just to experiment with it. But most importantly, OpenShift actually makes it a hell of a lot easier for you using something called routes.
Which is nice.
It truly is. Like, it's 2 commands, and you're like, oh, it just works.
There's your app. It's online.
It's so awesome. You don't have to worry about YAML over in the left-hand side. Now it's just
I will say ingresses are hard because they're networking, and there's a lot to just getting the ingress up and running and working. Where as a route, we kind of have, it came along before ingresses, and we knew like these need to be easy, right? Like for our enterprise customers to like just stand up and go, and for our developers to just be like, okay, here's this endpoint test on it, right? So that's why we built routes, and that's why there's a difference. we try, and we have contributed some features from routes into ingress, and we try to keep those as compatible as possible, but there are differences between a route and an ingress. And as you see, the simplicity of setting it up is one of them.
Really, truly is brilliant. Like that was one of the things that kind of was like pushed me over the edge of understanding.
That's what won me over on the OpenShift side was routes, to be honest with you.
Yeah, like it's just like as if I was Jane Doe developer, right, trying to get something out to production, and it was like 2 commands to get my thing working. I mean, come on, like how does that not? Anyway,
even if it's in test, right? Like, yeah, exactly. I think this thing works. Let me open up an endpoint and we can run our test suite against it. Ta-da! Exactly. Right? Like, there you go.
Normally, the presentation that I have, I'm talking to people who know nothing about Kubernetes. So I talk about the ecosystem. We all know what Helm is. It's the package manager. I know it's not a package manager, but it's a package manager. We all know that. Istio, service mesh, completely out of scope of this conversation, but you should at least know about it, especially because IBM spends a lot of money trying to use it and support it because it's cool. Just saying. Cool. There you go.
It is very cool. Knative is also very cool.
Very cool. If you play in the serverless world, take a serious few moments to look into Knative. It's moving rapidly too, but it is, if you have the use case for it, it is phenomenal. But remember, not everything is a nail, right? Like you not everything is a hammer, not everything's a nail. Do your homework. But if you do actually have the Knative use case, which there are very strong opinions on the internet, if you've heard about what that use case is.
People have opinions on the internet?
I know, right?
News to me, man.
Crazy. Okay. All right.
Anyways.
So, fine. We've all talked about this.
All great projects. Istio, Knative, love them. They're great.
Yep.
Let's get to the COBOL. Let's get to the meat and potatoes.
Exactly. So, when we think about COBOL, we already alluded to this first. We think of 2 random engineers in some data center playing with some tape drives.
Reel-to-reel tape drives, yeah.
Yeah. For some reason, he has an Emacs keyboard in front of him. Hey. Nope.
Poor chat. Oh gosh, so much moderation to be done here in a few seconds.
Sorry, I had to. I absolutely had
so many key bindings. Anyways.
And we do this weird green on black text kind of thing going on. It's weird. Like it's not what we do in a normal face. So this is what we think about it. But believe it or not, it's not. It's actually not. These are data center machines right here.
I remember reading that first article. Yeah,
exactly. So it turns out COBOL first.
JJ, I lost you.
How about now?
Gotcha.
There we go. Okay. Sorry, I get animated and I hit the mute button by accident.
Oops.
So first of all, COBOL is a standard. It's not actually a language, right? If you didn't actually know that, there are multiple different ways. Well, I mean, there is a language, but it's a standard of it's a spec to be able to get things done. There's multiple different versions of COBOL out there. The one that I'm going to be showing off is GNU COBOL, but there's the IBM versions of COBOL. There's all these different compilers out there. And the most important thing to know is that it is actually a modern language. It has a lot of the main, the ways that modern day development works already upstreamed into COBOL. And there are like bi-yearly releases, and there's true CI/CD on top of it too. The more you look into COBOL, the more you actually see modern day development practices. It's just because I'm wide swaths of statement here, because it's so like obfuscated into the data center, we don't see it in the front. We don't see it like how normal things are, how people like computery people nowadays do stuff. We don't see it because it's so far back in the data center, but they do have all those best practices. It's amazing.
And I think it's important for me to point out that the one job that I worked at where we had mainframes in our data center that was attached to the building, that team was amazing, right? Like I never had to talk to them, right? I never had to talk to them. They just did their job. And it was like the epitome of like the Patriots style, like Bill Belichick, football, like do your job. And that mainframe just did its job. That Z system did its job. And it rarely, if ever, gave us problems.
Chris, do you know what IBM Z actually stands for?
No.
I just learned this the other day from Liz. It means IBM zero downtime. It is the actual name.
Are you serious? Stop
dead
it.
serious. Yeah, zero downtime. I mean, it's actually what it means.
I'm gonna look that up. That's crazy. Right. I can't. I mean, no, I believe you. Like, but I want to know like the decision making process, right? Like, who was crazy enough to say zero downtime? Like, we guarantee this in the product name, right? Like when it came out all those years ago.
Exactly. Like you start thinking about it and it just spiders and you're like,
right. And that's why Kubernetes on mainframes is so interesting to me, because you get the resiliency of the mainframe and the flexibility of Kubernetes, right? Like this is why I think it's so powerful as a combo. Yeah.
Exactly. So amazing. And one last stat, just to make sure that obviously, hopefully the audience is well understood how serious COBOL and in our ecosystem is as a human beings. But it is true that 87% of all credit card transactions, nearly 8 trillion payments a year, all run on COBOL, right? On mainframes.
Yeah.
When you decide to go buy something, somewhere down that pipeline of however the transaction's done, there is a COBOL application running that.
Yeah. And
the more you think about that, you start seeing, anyway, again, that's very, very important to know. So let me actually talk about our ETL pipeline now. So my goal was to my initial goal of this whole like science experiment I put together, which ended up as COBOL and Kubernetes, on Kubernetes, which was I want to basically prove that any language can run inside of Kubernetes. It's that simple. Like because the whole idea of containerization, and what better thing to choose than COBOL? It is because it was so integral to our world, but it's not in the forefront of our minds anymore. So if you actually look on the right-hand side here, this is my 76-line COBOL application that takes something from Cloud Object Storage from IBM Cloud, and then it goes ahead and adds 5 to those numbers, and then outputs it to the console. So in essence, it extracts from their equivalent of S3, runs some COBOL against it, and then puts it somewhere else. It's a very basic example, but it encapsulates everything we need to.
Okay.
And if you go to here at the bottom, that link right there, it's COBOL on K8s is the repo. Also, I said,
I'll drag it. I'll find it. Don't worry, folks. I'll get
the link. And then there is if you do on OpenShift capitalized or OpenShift capital O, I think capital S, I think I did it right. That there's the OpenShift version too. I just haven't. There's a couple of to-dos in there I haven't quite gotten done.
No worries. That's why I'm going to drop it in chat so people can see the to-dos and maybe help you out.
Oh, that'd be even better.
Yeah.
So right here,
oh my
this
God,
is the actual
420
container.
repositories. I'm sorry, JJ. You need to clean up your GitHub account.
I know. I do. I need to.
Oh my God, dude. You need a tool for this. This is bad.
Yeah. It's that's a different conversation, Chris.
Anyways, sorry. Yeah, my bad.
So back to what I was saying earlier, I went ahead and used GNU COBOL. Here is the actual Docker file that builds the container with the compiler inside of it. As you can see, it's just a CentOS build, CentOS 7 build, pulls down what's required, compiles it, and Bob's your uncle, which is cool. I have 3 scripts that basically do the same thing in just different stages, which is what we'll walk through.
Okay.
Again, if you've heard me earlier when I was describing it, this is literally the pipeline. It's very straightforward. We have an S3 bucket. We have basically something that W gets it, puts it onto a Kubernetes volume, runs some COBOL against it, and then dumps it out somewhere else. Nice. Real straightforward. So let's actually see it happen.
Let's do it.
So
someone dropped in chat, Thorsten Michaels on Periscope said, I got, quote, this is him saying this, so I can't verify this. I'm sure JJ might be able to, maybe. If Liz is watching, she could probably chime in. I got verified by an IBM specialist that a Z15 can run 2.4 million containers simultaneously.
Whoa.
That's a lot of containers.
That's a lot of containers.
I mean, I don't know if anybody that has if you need 2 million containers, wow, like good for you. Anyway, sorry to interrupt. Go ahead.
No,
That's amazing.
That's real good. That is truly amazing.
A Z15 is a kind of mainframe from IBM.
Nice.
Yes.
I do want to hawk a couple things real quick, just because I have an opportunity. If you didn't know, first of all, IBM has a cloud.
We do.
That was a joke.
They do. Yes.
Joke.
Yeah. There's a cloud.
There's a cloud. But we actually do have a full free forever tier. Just go to ibm.com/cloud free, which is great. The reason why I do that is because, believe it or not, you could get a free Kubernetes cluster from IBM Cloud that lives for a month, and then gets destroyed, and then you can just recreate it and have another Kubernetes cluster free for a month. So if you do it properly, in theory, you might be able to have a forever free Kubernetes cluster. I mean, it's not huge, it's not great, it's not huge, but the beauty of it is it actually, we can run our COBOL narrative on it. I even created some wrapper scripts around it, so you don't actually have to figure out how to go through the process of ordering it. It's just basically create.sh.
App.
Yeah. So as long as you
JJ's about to get a whole bunch of activity on his stuff.
Yeah. So in essence, you just put your API key in and put a name of a cluster, and there you go. Now you have a Kubernetes cluster. Just to kind of prove to you here, COBOL on KS. COBOL on KS. Just to prove to you, IBM Cloud cluster KS cluster KS cluster list.
I believe.
I never get that right. It's OS. As you can see here, I'm on my own cluster. I created it 2 hours ago, and it is just sitting there running. So what I'm going to do is I'm going to interface with it to run our COBOL and Kubernetes. So if you look here, everything is done inside of this deployment, where I have three containers inside of one pot. I use an init container to build it, and again, I've put this stuff all out onto GitHub, or sorry, on Docker Hub already, just because I put it there originally. I know I was supposed to use Quay.
Well, I mean, you have all the reason to move now, so.
Yeah, that's true. Good point. Very good point.
Also, good news. I just saw that GitHub is hosting all the Helm stuff. So everybody that was worried about the Helm chart stuff breaking, that is getting resolved. So.
Oh, nice. Nice. I didn't actually know that.
Yeah.
So the theory being is that if you do create one of these clusters or a Minikube cluster or whatever, you can just pull this, you can just run this manifest and see it run yourself, which is really neat. So I have this one container. I have an init container, create some directories, and then I have 3 containers that get spun up. One that is called the COBOL process, which I imagine you understand what that does.
What?
COBOL process.
Huh?
Then we have our watcher in, which actually watches in to see, to pull the thing down.
Okay.
And then our watcher out right here, which actually does the watcher out, pushes it out. One last thing to make sure that I'm not completely crazy. COBOL, KS. If you go into the scripts directory, here is the actual scripts. As you can see, it is a straight wget. And if I go ahead and wget, if I go to this guy, copy, paste, numbers.txt. As you can see, here's our little numbers.txt. Of course, I'm 1337. Got to always have it at the bottom, right? Nothing, maybe. There we go.
Of course. Why not?
Why not? So as you can see, we wget it down, and then we run our COBOL application, which is literally just another bash script, and it runs the process, which is nice. It is literally just running the application right there. And then finally, we just output it again here. Now, being that this is a brand new cluster, it's going to take a minute for everything to spin up, pulling everything down from the internet. Normally I have another cluster I do this on, but I figured I wanted to show this in a completely untouched, brand new environment.
Unfettered.
Unfettered. There you go.
Mm-hmm.
So let's go ahead and do kubectl get namespaces. And I can't type it for the life of me because everyone's watching me.
Right. That's always how it works.
Yep. So default, it's been around for 124. So let's go ahead and create ns COBOL and create a namespace of COBOL. And then what we're going to do is just approve again, right? Completely. We're gonna dump this inside that namespace because we should be using namespaces.
Mm-hmm.
So what I'll do is I'll do apply -f deployment dash and then COBOL.
Very nice.
So then we'll go ahead and do get pods and COBOL. As we can see, we are initializing. It's going to take a couple minutes. Pulling it down from the internet, which isn't too bad. There we go. It's already initializing. And then what we can do is kgpod or kgpods or no k logs pod this guy and COBOL. And just to prove to you, here we go. Here's our 3 different pods inside of it. So I can do C. Let's watch our watcher in. And as we already saw, it's done the wget, pulled it down, moved into there. So then we can take our COBOL process here. Again, we're already halfway through, or a third of the way through our prop pipeline because we've already extracted it. And now we're transforming it. And there we go. And 1337 plus 5 is what? 42, right? So we've already processed it. No worries. And then finally, out. And there we go. We've written out our new file to the new location. And that's it. Like that's
and
it.
70 lines of COBOL.
Exactly.
And a billion lines of YAML, which speaking of, so someone in chat actually wants to know, like, how do you manage indentation in YAML in Vim?
Oh, yeah, that's a great question. So the way I've done it, especially here, first of all, if you ever need to, because we all are developers and we all copy code from the internet and Stack Overflow, set paste right there is your friend. You always need to do set paste before doing anything, because that'll take the exact same output from your, you know how when you paste something into Vim, it gets all weird like
and everything. Yeah.
Set paste gets past that. Okay. And then if you were worried about indentation and or tab characters, if you do set list, this will actually show you the tab characters inside of it. So as you see, the $sign is the end, and if you see it, there's this $I, which will be in a weird color, and that's a tab character. Okay. The beauty of this, if you've noticed that I don't have any like highlighting or anything like that, is because the way Vim by default works, it will always stay on the same column. Column, yeah. So if you see like this metadata right here, this is under spec. So I know that there, and it keeps going down if you're in insert mode and you're just using J and K, as I'm doing right here. And then also another great thing that you should do if you're learning this on down the line is Control D is page down and Control U is page up in insert mode. You'd be amazed on how much life gets better when you start doing that. Did I answer the question?
I feel like it. Yeah. I mean, you're just you're being very prescriptive to VI. Yeah.
And as much as I'd like to say, vimadventures.com is worth every penny.
Every single penny ever.
Yes, it truly is. You learn so much. It's unreal. It really, truly is. So here we go. Here's some links just in case you haven't seen it. Chris, if you want to steal those. As you see, COBOL and OpenShift, COBOL and Kubernetes, and OpenShift runs on Linux Z2. That was that link we were talking about earlier, which is great. If you are curious at all about COBOL, IBM has some amazing learning paths and tutorials, just go to developer.ibm.com/technology/COBOL, which is great.
Mhm.
And then here's some, if you're playing in that world, there's even a VS Code plugin for IBM Z, and some if you're using VS Code. I do that when I'm doing development. When I'm doing sysadmin things, I'm in Vim, but of course I have my Vim bindings in VS Code just because the way I am.
That's the way I am too.
Yep. But it's obviously in this example, I only need to use Vim. So here's some useful links. And then finally, thank you for your time. Again, my email address. And if you do want those slides, KDS-COBOL. This, and I didn't say this at the beginning, and I'll say it now. This is not production code. You cannot just take your COBOL application and dump it into Kubernetes. This was just a science experiment to show that this is possible.
You call it a science experiment.
This was just a step forward to show you that there are ways you can start thinking about it in different ways. But this is not, you. If you know what Kix is, you're not going to be playing with Kix and COBOL and Kubernetes anytime soon. There's a whole world of this stuff that you need to look into. I just wanted to prove that the Venn diagram of COBOL engineers, the Venn diagram of cloud native engineers, and there's an intersection there that we can actually show how things can come together.
Oh yeah. And I think we're showing that every single day, with the Red Hat and IBM thing, right? Like just the fact that we, prioritize getting, I mean, I know we were working on it, but we really prioritized it after the acquisition, obviously getting IBM working on Z or OpenShift working on IBM Z, because that's a lot of hardware that's out there already, right?
Exactly.
Like that is a big install base that we can leverage, right? Like when you take zero downtime hardware and pair it with zero downtime software, supposedly, it can be an incredibly powerful platform to do a lot of different things.
Exactly. It's the challenge now is it's back to what's the same in your call to action at the end of what you say, right? Is that hopefully we've spurred some thought in someone's mind who watched this and was like, oh, interesting. And that right there is that call to action. Dig a little bit deeper. Reach out. Let's have a little more conversations.
Yeah, feel free to reach out to me, Chris Short on Twitter, C Short at Red Hat, and awesome at IBM.com, and JJ Ascar, all one word, on Twitter, if I remember correctly. Looking at the chat here, there's code ready workspaces for OCP4Z2. Yay. Yeah, so people are pretty happy and like generally pleased to see this, right? Like this is cool stuff, man. You're doing great work. This is cool. I love it, right? Like taking that marketing teacher's advice from 93, and then now it's still applicable, right? Like, but even more so, we need to think about COBOL in a cloud native way, right? Like, how do we do these big, huge kind of ETL pipelines in a cloud native way? It's pretty amazing, right? Like, and taking it even further, right? Like, once you get to this level of zero downtime hardware, zero downtime, application, what else can you do? Like without those limitations, right? Like when you think, what does 100% uptime really look like?
Exactly.
Right? Like I know that's like kind of a pipe dream and reality, right? Like applications need to get upgraded and everything else, but there are ways to do that so safely in OpenShift and Kubernetes that you don't have to necessarily worry about it, right? So now you're thinking, okay, 100% uptime could be a theoretical possibility. Right?
Yeah, like wait a second, wait, what can I do now?
Yeah, what is now possible because of that, right? Like if you engineer your entire infrastructure for zero downtime, what can you do there? Like that's going to open all kinds of potential for you, right? Like I don't have to worry about it. There's not going to be any downtime. I'm going to upgrade this app. I'm going to do this thing. I'm going to do that. I'm going to try this. I'm going to experiment with that. And we see what comes out of it. And you're going to get some pretty interesting things, I imagine. So yeah, I know an IBM Z15 system costs $160K according to Narindev, but you're paying for the 100% uptime, right? Like
And we'll put that in perspective real quick. Think of an AWS bill of
Right,
116K,
exactly.
right?
You're
Like,
not getting
think about that for a
100%
minute.
uptime.
Yeah, think about that for a moment.
Mhm.
Wait a second. There's possible people watching this video whose OpEx alone is 116K a month on AWS, right? Like
Easily, yeah.
there's a possible of that. And then now you now have a box that can be up 24/7, zero downtime,
Mm-hmm.
that you can get your code. I mean, the possibilities are just mind-boggling. Anyway.
Yeah, like someone asked, will there be SREs in the future? Who knows?
Yeah.
There'll be somebody there to keep the lights on for sure. But I mean, think about it, right? Like generating electricity used to require a lot of people and a lot of stuff.
Mm-hmm.
Now a lot of it's automated and a lot of machines do it. Building cars, same thing. Now a lot of it's done by robots, right? Like infrastructure is going to get to this point where it's something we don't worry about anymore.
Yeah, it's the same story of like when I used to talk about with Chef and using automation, and now I talk about with Ansible for obvious reasons. The people are worried, are like, well, I've been training how to do this job for so long, I'm going to lose my skills. Well, you're looking at it the wrong angle. You're seeing it as a threat. What you should see it as
opportunity.
An opportunity to grow, to do something else, because who knows, that one thought you've had in your mind, but because you've been dealing with something manually for so long, you haven't been able to get to, might change your whole life ecosystem, your whole job, your whole company, because now you trusted automation to do the work for you, so you can spend that cognitive overhead working on something else.
You know what I rarely do anymore? Touch a light switch.
Really?
Yeah.
Oh, yeah.
Yeah.
Yeah. Yeah.
Yeah. Think about all the time I've saved not touching a light switch over the course of, I don't know, 4 or 5 years since I've had the system in place. Well, 3. I mean, but think about that, right? Like I touched 2 light switches in my entire house, I think, maybe 3, right? Like it's crazy.
It's true. It is so true. Like, yeah, like how much time have I spent just to play off of that? Of like doing decorations outside for like holiday season, right? And all those times I'd have to go out and plug in the extension cord. And I got one of those things that talks to Alexa on a timer, right? Yeah. So I can tell Alexa to go turn the stuff on if I want to, or
set it up to do it at sunset and sunrise. Yeah.
Exactly. And it just does everything before me. I don't have to think about it.
Just does it all for you. Exactly. Exactly. Right. Like, and that's the beauty of automation, right? And that's where you win, right? That's how you win. Automation leads to so much more, because now I'm setting up Kubernetes clusters in my house because I don't have to worry about turning on light switches potentially, right? Like, who knows, right? Like, there's all this other stuff happening now.
Yep.
Because I'm not wasting time with plugging in a cord or flipping a light switch manually. I'm doing fewer manual tasks and more automated tasks.
Exactly.
This is awesome. This has been a great show, JJ. I really appreciate your time today, man. This has been awesome.
Hey, no, Chris, all you gotta do is ask, buddy. And I'm here.
Yeah, I know. No, I know. You know how busy I am, though.
Yeah, I know.
You've seen my calendar.
That's true.
On the other hand, are you doing worse, more complex things because you don't spend time doing simple things? Maybe. I mean, yes, potentially you can automate away all the simple stuff and do nothing but the hard stuff. That's kind of the idea, right? Like spend the human capital, right? Like that ability to troubleshoot and problem solve does not exist in a computer. It exists in the human. The human has to tell the computer to troubleshoot and problem solve, right? So like take the human and put it where the human does the best stuff and make sure the computer does the rest, right? Like I don't worry about YAML. I have YAML lint, right?
Exactly.
I hit save, that thing gets linted, right? Like, so yeah, I mean, the automation helps at every step of the way, right? The
XKCD article, or the XKCD automation graph is perfect in this state. Like, yes, you're right. You're going to, like if it's just XKCD automation, I think it pops like right up. But to your point, yes, you're going to be spending more time doing complex things. But the beauty of it is, I mean, if you had manual tasks and complex tasks to deal with, right?
Mm-hmm.
You still had to do those manual tasks to get to the complex tasks. And there's fatigue there, right? There's fatigue to get to that point.
Yeah.
If all those manual tasks are automated tasks, now you can spend your time doing those complex tasks with less fatigue, which in theory allows you to open up to do more. And before you know it, you're actually having dinner with your family at a reasonable hour. Right?
And not getting woken up in the middle of the night.
Exactly.
That's the dream, right? That's the dream. All right, everybody. We appreciate you joining us. Thank you to our guest, JJ, so much. Appreciate you coming over, showing us some COBOL. Check us out tomorrow morning, 9 a.m. We start our full Wednesday schedule, as usual, with the Level Up Hour, the one and only Langdon White. So 9 a.m. Eastern, 1500 Central Eastern Europe Standard Time. And yeah, we'll see you then, folks. Have a good one. Thank you again, JJ.
Thanks.